So far in class, we've taken simple ideas, simple-ish ideas, excuse me, and used Bragg's law, which is really, it is not quantum chemical in nature. We have to move to something a little more quantum chemical, which means we have to talk about electrons as waves. Yeah, waves. They are, but are electrons, what are electrons? Are they waves? Are they particles? Both, and depending on the experimental conditions you set up, you can make them behave like one or the other. Before we do that, we have to remind ourselves of some mathematics. Of waves. Okay. A standing wave. Or actually, it doesn't have to be a standing wave, but it can be any waves. How can we mathematically express them? Yep, there's sines. Sine x, cosine x. We don't want to deal with tangent. Well, actually, yes, there is tangent in there, but I don't want to deal with tangent. What? It's a pain to integrate. Yep, and you can always turn it into something better. You can always turn it into a combination of sines and cosines. I get why mathematicians do what they do, but in reality, you can convert it to these things. What is another? Yes, e to the what? Close. E to the what x? Ix. Yes. So we have imaginary components. No. The relationship between them is given by Euler's or Euler. How does everybody in math says Euler, correct? Yeah. Yeah, I know. They don't like that. Does anybody know the relationship between them? E to the I. We're going to use theta. Yep. Okay. That seems kind of weird because I is an imaginary thing. Imaginary things we cannot observe. So it's kind of strange. But we're going to use this numerous times through our discussion today. Everybody okay accepting this or remember this? Yeah.
I don't remember why sine is the imaginary thing. I know I've read it before. It's awful.
Yeah, it has to deal with, you can use trig, you can do a couple other things. And what is it, cross products and dot products is really where it comes from. I don't want to derive that though, because it takes too much time. Okay, continuing on, the other aspect we have to talk about are phase shifts. So if you have two waves, how in sync or out of sync they are with one another. The way that we're going to apply this is we bombard an atom with X-rays, and it will be scattered and the phase will shift. And we have to try to figure out how far apart the waves are from one another. So the ones that are left unperturbed versus the ones that are perturbed by the electron density. So this is often called a horizontal shift. And this happens when radiation is scattered. As an example, we're going to plot sine of x, and Joe, you can see blue as a different, right? Compared to white. Sine that. Here's our plot. We're going to plot from 0, pi, to pi. What will the plot of sine x look like? Where should I start? 0, yep. It's going to reach a maximum at where? Yep. What's going to happen as we go to pi? Yep. And then where's the minima? Halfway in between, and then we go up there, right? Okay. Sine of x minus 2 pi, that one shifts everything by a factor of what? Yeah, pi over 2. So where would we start here? We're not going to start at 0. 0. Then where is the maximum going to be? Mm-hmm. We go back down that way. The phase shift. And we have to have a comparison between sine and our new function is what? Yep, pi over 2. The scattered wave is the one that's considered shifted. So it's all relative to the unscattered wave, which is important. The maximum, sorry, I drew it pretty bad. It should be at pi. It's at pi. Yes?
Or like if it's positive or negative, that would be relevant here, right?
It is. If it's positive, it pushes it actually this way. Negative shifts it this way.
Okay.
Your daily problem has to deal with plotting 3 different functions this way and figuring out what the phase shift is. So you're going to get use with that. Joe, you had your hand up again.
No.
Okay. All right. Do you guys remember and or accept this? Yeah, Joe, what's up?
So for the phase shift, does
Yes.
it also go to the minimum? Like
Yes, basically what we are doing is we're moving this function over. So the white function's moving over to where the blue is. And what is the difference between there? Does that make sense? Okay. So you can think about this as an X-ray that hasn't hit anything. This is an X-ray that has been bounced off of an atom. No, they're not out of sync.
They're out of sync with that making it.
No, it depends on where and when you're talking about them being out of sync or not. Okay, so these two, they do have constructive interference. Where is the constructive interference? Yeah, so when they're overlapping, like at these points, that's going to be the maxima. So you can actually add these up and figure out where the maximum intensity is. So it depends. A situation, where would they be completely out of phase? What would the phase shift have to be? It'd have to be pi. In that case, boop, they are destructive and you would see nothing. Does that make sense? So you can literally just add these two functions, the result of these two functions up. The amplitude changes though. That's why I left it off. Okay, any other questions? Good question, Joe.